Okay, here's another example using a rate times time equals distance table. This one reads, a machine A can assemble 15 parts in 1 minute. Machine B can assemble 20 parts in 1 minute. Machine B begins production 15 minutes after machine A does. Let T be the number of minutes that machine A has been assembling parts. There's no question here. Hold on, let me get a question. Okay, now we actually have a question. Sorry about that. Forgot to write the question in. If 20,000 parts are ordered and the machines run as described above, how long must machine A run? So this is supposed to be must. I don't know how it wound up much, but this is supposed to be must. Machine A run. Okay, so there's no distance involved here. Is this a rate times time equals distance problem? Well, of course it is. It just isn't like the rate of a car and the distance that a car travels. Instead, it's the rate the machine runs and the distance is how many parts it makes instead. It's the same thing. It's rate times time. So the machine makes 15 parts per minute. Therefore, you're multiplying the number of parts by the minutes to have the total parts. So again, you might be able to solve this without a table, but I'm going to make a table because that's the skill that I'm trying to get across to you. So rate times time equals distance. All right, and make a table. Sometimes these tables have 2 rows, sometimes they have 3 rows. I don't know if this is going to have 2 or 3 rows in it or not. Now, it's very important to determine our variable. It doesn't say what our variable is. Oh, it does. Let T be the number of minutes that machine A has been assembling parts. Okay, so that's our variable. T is the number of minutes that machine A has been running or assembling parts. So we're going to have machine A here and we're going to have machine B here. And machine A has been running for T minutes. And it makes 15 parts every minute. Therefore, its distance, so to speak, its number of parts it makes is 15t. Isn't really distance, but 15t. Now, B runs and makes 20 parts per minute, so it runs faster, but it starts later. So here's where you do T. T is based on how long A has been running. So B has been running 15 minutes less than that. So that's T minus 15. Therefore, B produces 20T minus 300. I'm distributing, right? I'm multiplying 20 times the amount of time it's running. All right. So 20T times 300. In other words, it makes 20 parts per minute, but during that first 15 minutes when it didn't run, it didn't make 300 parts. Okay. So we want to know when the total of that is equal to 20,000 parts. Now, we don't know how much time here. I guess we could add those 2 times and get 2t minus 15, I suppose, for time. But we cannot add rates. You can't average these rates or you don't do anything with those rates. Don't try to do any math with those rates. Your equation winds up over here. All right. And that equation is 15t plus 20t minus 300 equals 20,000. And then you go ahead and solve this. So we have 35t, and the 300 will move over to the other side, 20,300. And if you divide, now you have to divide the 20,300 by the 35, you get 9.6 repeating. Oh no, you do not get that. You get some much smaller number, no, much larger number than that. What do you get? I did this earlier. You get 580 minutes. You get 580 minutes, which is not easy to understand until you divide that by 60. And then you get 9.6 repeating, which is the same as 9 hours and 40 minutes. All right, 9 2/3 hours. All right, 9 hours and 40 minutes is how long machine A runs, which means machine B runs 9 hours and 15 minutes, less than 40, 9 hours and 25 minutes. Okay. It's another rate times time equals distance example, written a totally different way. It feels like a work problem. We're going to do work problems separately. They work differently. This is not a work problem because in a work problem, you're not given a rate the same way. You're given a rate in a different way entirely. So notice that this is something that happens per time, 15 parts per time or 50 miles per hour. Those are parts per time. Those are easy rates to deal with in a rate times time equals distance table. Yeah.